Hello everybody, this is Mr. Carey coming back to you with another GoMath 4th grade lesson, and this is going to be lesson 4.3, Interpreting the Remainder. Now in lesson 4.2, we actually learned about remainders. Remainders being when you divide something and you can't do it equally and you have leftover pieces. And so we learned about what remainders were, and we learned how we can write them. If I'm, let's say, doing 7 or 22 divided by 7, I know 7 times 3 is 21. I have 1 left over, and so we've learned that I can do 3 with the remainder of 1, and that would be my answer. Today, we're going to learn actually about interpreting that remainder. What does that mean? Do I always want to use, the remainder 1? Can I use other different ways? And the answer, of course, is yes, especially with Common Core. There's lots of different ways. And the first way we're going to learn is using fractions. Now in my warm-ups, a lot of my students, we've had a lot of questions about fractions and adding them. So this will be really the first time that we've actually come in to using fractions in our curriculum. So we're going to use this math problem to interpret our remainder using fractions. And I'll explain why we would use fractions. So Megan has 73 inches of leftover wallpaper. She wants to cut it into 8 pieces, and each piece will have an equal length. How long will each piece be? And this is on page 151 of our GoMath text. And so first thing I'm going to do is, of course, highlight the information that I need. And I'll highlight it in red. She has 73 inches, of leftover wallpaper. We care about that. We care about 8 pieces. Right, she's going to cut it into 8 pieces. And then how long, how long each piece be, right? Will each piece be? So that's what we care about. Now something else that we care about why we're using fractions is this little piece right here where it says will have an equal length. Now that is key as to why we're using fractions. So the first thing we need to look at is our information, right? So we have 73 pieces or 73 inches of wallpaper. And I need to divide that into 8 pieces. So what it's going to look like is 73 divided by 8. Or if I want to make it more manageable, remember we switch it around, 8 divided by, 73 divided by 8. And that's the same exact math problem. This is just more manageable, and I'll show you how it's more manageable right now. First, let's look at what is the divisor, right? In my math problem here, what is my divisor? What am I dividing by? That's right, if you said 8, that is correct. 8 is my divisor. So then that would leave, that's right, 73 inches as my dividend. Very good. All right, so let's see what this looks like. Let's do our division. All right, so let's do 73 divided by 8. So when we're doing division, what it's basically asking us, and I'll write it over here to reference it. Obviously if I take 73 and I divide it 8 times, what's my length going to be? Well, if you're, this is where multiplication comes in, right? If you aren't really sure, well, think of it like this. Here's my what times 8 gives me 73? Or in this case, gets me close to 73. All right, so if you said, we can just start off with 10, right? If you're not sure, if you're still not sure, let's start off with 10, okay? So 10 times 8 gives me 80. Well, unfortunately, that's too much, right? 80 inches. We don't have 80 inches. We have 73 inches. So we can't use 10 times 8. Well, let's go down a notch then. Let's do 9 times 8 gives us 72. Perfect. That's less than 73, so we know we can use 9 times 8. And so what we're going to do is we're going to put that over here. We're going to put 9 times 8. Because that's what this is asking me. What times 8 gives me 73? Or 73 divided by 8 gives me what? So 9 times 8 is 72. So I've done 9 times 8 gives me 72. So now I need to figure out the difference, right? 73 minus 72. So if you're stuck here and you're like, well, okay, Mr. Carey, how do you know we're doing subtraction other than you know? Well, let's go back to lesson 4.1. Remember we used multiples to find our division problem. So remember, I'm going to use multiples of 8, but I'm not going to start off at 1. I'm going to start off at, let's start off at 6. 6 times 8, 7 times 8, 8 times 8, 9 times 8. Okay. Now remember, this is what I'm dividing by, my divisor, 8. These are all multiples. These are all how many inches, right? So remember, I have 73 inches. So if I were to divide whatever I have by 8, I should have 6 pieces. So 6 times 8 is 48. So if I had 48 inches of material, I could divide it 8 times and each piece would be 6 inches. 7 times 8, 56. Same thing. If I had 56 inches of leftover wallpaper and I cut it 8 times, I would have each piece be 7 inches. 8 times 8 is 64, and then 9 times 8 is 72. Now we already know if I went 10 times 8, it would be too large. But this is where the difference comes in. I don't have 72 inches. If I did, everything would be great. 72 inches of wallpaper divided by 8, and I would have each piece would be 9 inches. But I don't have 72. I have 73 inches. Okay? So this is where the difference comes in. I know 9 times 8 gives me 72. But that's not quite enough. What is the difference between the number I have, right? 9 times 8 is 72, and the number I have is 73. What is the difference between the number I have and then the multiple that I used, 72? That's where this comes in. That's where you have this difference. That's why I subtract. That's the number I have. That's as close as I can get to it. So 9 times 8 is 72, and then 73 minus 72 gives me 1. Okay, now if we were doing this as in 4.2, then we could just say 9 with a remainder of 1, and then we're done. The problem is this doesn't really help Megan at all, because we can't tell her you're going to have 9 pieces with a remainder of 1, because that doesn't really mean anything to her. She doesn't know what 9 with a remainder of 1 means. So that's why we need to interpret it. So let's interpret it. So let's say, and this is why I said at the beginning, what is my divisor and what is my dividend? So my divisor, remember, is 8. My dividend is 73. So now, instead of having 9 with a remainder of 1, this is how we do fractions, okay? Remainder over divisor. And that gives me a fraction. So let's test it out. 9 times 8 is 72. 73 minus 72 is 1. Let's put the remainder on top. And then my fraction. And then what's my divisor? 8. And guess what? We're done. Let me put the units, inches. So how long will each piece be? Well, each piece will be 9 1/8 inches long. Now I can test this because I know, right? If you think about it, it makes sense, okay? Because 72, if I were to do this, 72 divided by 8 equals 9. 73, I mean, it's just a little bit more, right? It's just a little higher, 1 up. So it makes sense that my answer would be just a little bit more than just 9. I have 9 1/8 inches. So, and that's the whole answer. That makes sense. Because if we're using length, you know, Megan needs to know exactly how long. She's got a ruler. She needs to know exactly how long each piece is going to be. And if we were to visualize it, right, it would look something like this. Here's my piece of wallpaper, right? It's flat. You can't really see it. And I'm cutting it into 8 pieces, right? So I know this is 73. If I'm going half, there's fourths, and that's about eighths, right? 1, 2, 3, 4, 5, 6, 7, eighths. So I need each piece to be an equal length. So each piece is going to be 9 1/8, 9 1/8, 9 1/8, 9 1/8, 9 1/8, 9 1/8, 9 1/8, and 9 1/8. And we can check this out. Watch. What's 9 times 1, 2, 3, 4, 5, 6, 7, 8? 9 times 8 is 72. Now I have these eighths. Now a lot of us, we learned in class, in our warm-ups, when I'm adding fractions, I just add the numerator, right? So I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. We have 72 8/8, which 8/8 is equal to 1, which means I have 72 plus 1 gives me 73. Pretty cool, huh? So that's using fractions to interpret the remainder. So let's try another one. So there's one at the bottom where Daniel's making soup. And let's use that because that's another instance of where we would want to, we want to use fractions to interpret our remainder. So let's use this. So the question is, Daniel made 32 ounces of soup. That's, for those that, if you're looking at this, OZ is abbreviated for ounces. Ounces of soup for 5 people. Daniel's very nice. He's going to share his soup with 5 people. How many ounces will each person get? How many ounces will each person get? Okay. So this is another instance where we'd want to use fractions because it just makes sense. Again, whatever I come up with the answer, I wouldn't want to say, Daniel, you're going to have, whatever, let's say it's 7. You're going to have 7 ounces with a remainder of 2. Again, that doesn't mean anything to him, so that's why we kind of need to interpret it for him. Using fractions. Okay, so remember, to start this, we need to figure out what is my divisor and what is my dividend. So remember, my dividend, right, that's my, usually, for right now, is my bigger number, right? It's I have a big number of something. In this case, I have a big number of soup, 32 ounces of soup. And I need to divide it by 5 because of 5 people. So it's going to look like 32 divided by 5 equals what? Or 32 divided by 5. This is my divisor. And this is my dividend. Dividend. Good. So we don't really need this anymore. But remember, what is my divisor? It's 5. We need to remember that because we're going to use fractions again. Okay? So, let's set up my math problem. So remember, we need to find out how many ounces will each person get if each person's getting 5, right? And we can draw a picture, right, to look at this, right? Here's my soup. There's my soup, okay? And I have, let's see if I'm going to cut it into fifths. Let's see if I can get close here. There's 1, 2, 3, 4. 1, 2, 3, 4, 5. I know they're not equals, but that's my drawing. So that's 5, right? If we're looking at soup, I'm cutting it into fifths. So that's kind of what I'm looking at, right? Remember, total of 32 ounces, and then each one is going to get a fifth. So this is 1/5, 1/5, 1/5, 1/5, 1/5. This is where, again, fractions come in. I'm taking a whole and dividing it into fifths. All right, so let's look at what that looks like. So 32 divided by 5. So now, again, look at 5 times what gets me 32? Well, in this case, there isn't a multiple of 5, but what gets us close? 7, yeah, 7 will get us close. I think it's a little too much, though, all right? 7 times 5 equals 35. So that's too far away. But let's go down one. I think that'll work, right? 6. Let's try that. 6 times 5 gives us 30. Perfect. Now remember, we're going to find the difference between 6 times 5 is 30 and then our dividend. So then we're going to put the minus sign there. And now we go 32 subtracted 30. 30 subtracted from 32. 32 minus 30 gives us 2. Excellent. And now, remember, when we're doing fractions, remember it's remainder over divisor. Perfect. So let's take our remainder is 2, and then our divisor is 5. So the answer is how many ounces will each person get? Each person will get 6 2/5 of an ounce. 6 2/5 ounces. So that's, not a lot of soup, but maybe Daniel made a really good soup, who knows. But that's our last little one we're going to be doing with fractions. I'm going to stop this video, and then my next video is going to be 4.3, and we're going to explore the 3 other ways to interpret the remainder. So this is Mr. Carey signing off for now, and I will see you in a few minutes as I spin up other ways to interpret the remainder.